네, 여러분 안녕하세요. 가을바람입니다. 오늘은 아이온큐의 마가렛 아라카와 최고 마케팅 책임자 모시고 오늘 퀀텀 코리아 2025에 이렇게 또 아이온큐 분들이 많이 와주셨어요. 그래서 이 안에 미팅룸에서 사전에 조율했던 질문들을 가지고 인터뷰를 나눠보도록 하겠습니다. Hello, Margaret.
Hello, how are you?
I'm good. How are you?
Very good, thank you.
Are you having a fun time here in Korea?
Yes, I love it. I've been loving it. The food, the people, the technology, the buildings, everything. It's great.
We'll start with the first technical question. It's kind of very long, but I'll try to make it short. So we know how to scale out our technology to at least 10,000 qubits on a chip, the size of a thumbnail. Probably 100,000 doesn't look too scary. This is actually mentioned by Chris Ballas, CEO of Oxford Ionics. So does that mean future IonQ's quantum computer will not need photonic interconnects when you guys reach to 2029, when you plan to have 200,000 physical qubits and 8,000 logical qubits on a single chip?
Our strategy hasn't changed at all. We still will depend on photonic interconnects for scaling, whether or not because we are still in the process of closing the acquisition for Oxford Ionics. But as you know, we have stated that photonic interconnects is fundamentally part of our scaling strategy. So IonQ previously, as we get to larger and larger number of qubits, we still have every intention of having two interconnected systems to then double or to get from 100, 200, 2,000, 100,000. So that has not changed at all. And with the combination with Oxford Ionics, we hope to even scale even higher.
Then we would love to know at what point will IonQ will implement photonic interconnects to the actual quantum hardware that will be commercially available.
So we've already, for us, anything commercially available is we sell a unit that has that technology to a customer. So the 3 contracts that we have signed with the Air Force Research Lab, those all actually depended on photonic interconnects. And so we are actually currently on track to deliver what we have committed to as part of those contracts.
So that's more of a customized products for AFI, right? Not standardized like Pento or future quantum computers.
Well, that's where it's really great for the company to be able to deliver for the Air Force Research Lab what they need for photonic interconnects. But we also have the same scientists working on that for additional commercial opportunities.
So we could expect to see that technology implemented maybe within 2 years?
Well, we are already implementing, like I said, in the Air Force Research Lab work. And so you should expect that we're going to consistently develop that and develop it for all of the systems that we're going to produce going forward.
So no specific timeline yet?
Well, for right now, as we had noted before, we are firmly committed and on track to deliver AQ64, as well as up to 100 qubits on tempo, and we're on track for that. So the scaling and the need for getting to the 2,000, the 10,000, the 100,000, and 200,000, it's also part of our roadmap.
But on the blog, I saw that 10,000 to 20,000 will require interconnection. So maybe we could expect that's when we could actually see.
We're not committing to not using photonic interconnects earlier. Right, because like I said, the contracts we signed with AFRL, the Air Force Research Lab, that was in the end of 2024. So we have had a significant runway of working on it. So as soon as we continue to get more and more scale out of that technology, we will start implementing it. So I wouldn't say before or after, because it is firmly part of the.
The second technical question is, in the recent technical update webinar, IonQ announced plans to build 2 million physical qubits and 80,000 logical qubits with an error rate of 10 to the minus 12 power by 2013. So at that level, how commercially viable would the system be in practical terms? What kind of commercialization use cases are you anticipating at that stage?
So unlike a lot of other companies, we currently are working on applications on our current generation of computers.
Right.
So the Forte Enterprise 36 qubit computer, customers are getting commercial value from it because we're working on it with them now. So imagine that we're at 36 qubits now, we're getting to 64, and then we're going to get all the way to 2 million. The use cases, some of the use cases will be the same, but the complexity of the problem will get large. We'll be able to handle more complex problems. So, for example, we're working with AstraZeneca, AWS, NVIDIA on drug discovery, on helping to accelerate that process. Imagine at 36 qubits, which is what they ran it on, and they saw a 20x improvement versus previous instantiations. So then you look at that, have a much larger computer. Imagine the exponential capabilities of the complexity of the problem and the number of applications we can use, the number of drugs. Imagine that we can get to.
So we've been visiting QEra, IBM, and then IonQ booth. So IBM, they plan to show commercial advantage this year. They're planning to make it this year, and I saw IonQ's long-term roadmap, the detailed one. And it mentioned that broad quantum advantage may be on 2030. So should the investors expect to see a very big value created by quantum computer maybe around 2030?
So I think investors now and customers, partners, employees, shareholders, I think we're seeing commercially advantaged use cases now.
Right.
So IBM, IonQ, we are all working on current use cases that a customer finds value today.
Right.
And then, as you talked with the IBM folks and you saw their roadmap, we introduced a very ambitious, very exciting roadmap. And our roadmap goes to 2 million qubits physical and 80,000 logical. And right now, as far as I know, it is the most ambitious, largest number of physical qubits, logical qubits with the highest fidelity, lowest error rate. And we are currently working with applications, and we believe we can make the hardware for the most complex problems. So we have been talking about narrow quantum advantage and broad quantum advantage. Kind of like NVIDIA. In the old days, NVIDIA cared about 2 killer apps, video games and computer-aided design, right? There was no AI in the mix. It was just these killer apps. You think about Microsoft, where I worked for 20 years. Their killer apps were productivity, Office, and video games. Everyone loves video games. Video games use a lot and tax computers and make us better. But then Microsoft looked, after they built a foundation with those killer apps, then they expanded to all applications, and then they can expand from on-premise, hybrid, and cloud computing. NVIDIA, 2 killer apps in order to build the foundation, and then you get to AI, which covers all verticals, which covers, so think of it in that way. You always get great advantage in the beginning if you know what use cases to look at, and then you'll continue to get bigger and you'll be able to scale in broad quantum advantage as the years progress.
So it would be better if we see the bigger picture instead of too narrowly focusing on the details.
Well, I did bet my career and life on Microsoft early on. I bet my life on the internet would be big in 1994, before the computers were secure or fast. But it got me on to the train of understanding networking, compute power and all that. So I don't know anybody in the world that wouldn't have wanted to bet on Microsoft when the only 2 killer apps they had were Flight Simulator and Office. Because they were very robust businesses, right? Microsoft is still a player in the space. And then look what they built that into. Same as NVIDIA. Everyone should have bet on NVIDIA when it was just CAD and video games. In fact, anybody who'd bet on NVIDIA 10 years ago would have been prescient. And NVIDIA is still a very good company with robust revenues, right? And that's what we are.
Third one is, recently it seems that the photonic interconnect roadmap is experiencing some delays. At the same time, IonQ has expanded into quantum networking business. What revenue proportion does IonQ expect to come from these 2 areas? Which one do you anticipate will reach profitability fast and demonstrate faster revenue growth?
So we don't currently break out our revenues by division.
Right.
But again, like I said before, We are on track on our photonic interconnect roadmap. We know that we have a customer that we have worked closely with that is eagerly awaiting the outcome, so we feel very good about that. As far as which of the businesses, we're a full stack business. We do quantum hardware. A part of that hardware, we have quantum software and all the hybrid and OS services, do applications, and we do networking. All of that is what we believe will help us grow to become a profitable company.
So it'll be a true full stack quantum solution company.
Absolutely. In fact, actually, I was trying to think of an analogy. Okay, I'm going to try this, okay? Especially since I worked at some of these companies. So imagine you are HP and you're building out computers, but you need a BIOS and you need a chipset. So along comes Intel, which I interned at. So Intel has a semiconductor, they have chips, but they also have a BIOS. So then you have a hardware and some layer of software. Then Microsoft layers on an operating system that's the traffic hub of all of the applications that sit on top of it. That is the full stack that currently still exists, right? And then when you add in a layer like GPUs or the CPUs, it ignites the application layer above, right? The use case is now ML and AI. Imagine that happened, but there was no Cisco. If there was no Microsoft who did web servers or Cisco who built routers and switches, there would be no internet, right? So we are trying to build both the quantum computing stack, hardware, software, apps, and we know, because we've all lived in the day of computing and the internet, we need to help build the quantum internet. Because the quantum internet will scale power, but it'll scale communications, and as you know, it'll scale security as well. So that's our job. Our job is to work on all those parts and help bring it up together.
In a previous interview with Peter Chapman and Nicole Demasi, it was mentioned that IonQ's new quantum computer, Tempo, was expected to launch around July. I mentioned Peter told me that like 2 months ago. And is it still scheduled for release in the fall, or will this schedule be delayed due to application of new technologies through collaborations with the recently acquired companies?
We are on track to deliver a Tempo grade computer that we will test and be using internally, exactly as we said. So that's on track. So, and again, the acquisitions of, Oxford Ionics hasn't closed yet, but we have still, our entire company is focused on delivering AQ64 and a Tempo class computer that's capable of up to 100 qubits.
So, should we expect it within fall or within the end of this year? We will actually hit our targets for Tempo this year. That's what we are on track for, as far as our benchmarking and getting to that place. So that's where we're at. Okay. Will Tempo feature 64 algorithmic qubits as outlined in the previous roadmap, or will it follow the new roadmap where the AQ concept has been phased out and instead featuring 64 physical qubits? If it's the later, how many logical qubits will that translate to?
So on the webinar that we talked about, as well as what we have published, we have not gone away from our commitment to deliver AQ64, hitting that, because as you know, AQ64 was a benchmark that looked at all of the 600 classes of applications and use cases that it can be used with. We are on track for hitting that AQ64. And Tempo is the next generation hardware that we actually said that we are now able to deliver from 64 up to and over 100 qubits. So it'll be dependent upon what customers that we work with and what they need. But again, what's great, which is fantastic, is we see customers right now getting value from Forte Enterprise. If you go outside and you go to the AWS booth, the world's largest cloud provider, right on the wall that's next to us, as you can see, it says, here are the quantum computers that we work with, and IonQ is the first quantum computer listed. And they're very excited, and we announced that we have this, we've always had a strong partnership, but they were incredibly excited that they have access to a fleet of quantum computers, because they see demand for quantum computers using IonQ. So if we know there's demand for the current computers, that's fantastic. And AWS has given us that indication. So has AstraZeneca, so has ANSYS, so has AIST in Japan. So we've had so many customers that are eager today to use 36 qubits because they see value today. They're running the benchmark testing. They know what they did previous. They have a control, and they use just a 36 qubit computer or 24 qubits of that, and they see they can get 12% improvement or 20x performance. So they're excited to start now because if they can get that improvement now, they have to refine their algorithms. They have to train more people. They need to be deeply embedded now as the computers get even more powerful.
So in the recent blog, you guys mentioned that Tempo will have 100 qubits, but that's not, that could be determined on what customers want. So
Right.
that could be changed.
Like for example, when we landed our deal with Quantum Basel, we were very excited, and we announced at the time that we'd be shipping to them a Forte Enterprise with 35 qubits.
Right.
And we hit 35 qubits as a benchmark before we shipped Forte Enterprise to them. Forte Enterprise in Basel, Switzerland is currently enjoying 36 qubits because the hardware is capable of getting there. And we were able to fine-tune both hardware and software to hit 36 qubits. So in an example like that, a customer like Quantum Basel is not saying, no, I don't want the extra qubit, because extra qubits are exponential power, right? So they were happy that we were able to actually over-deliver from what the contract was originally talking about.
So on the new roadmap, the tempo doesn't show any logical qubit side.
Right.
So that's not officially.
We haven't announced the logical qubit side, but as you probably know, if you look at all of the quantum computer companies in the industry, most companies aren't announcing logical qubits, but we have on the long-term roadmap, and as we develop and land Tempo as a commercial quantum computer, just like we had the 4 generations before, we will start announcing that as well.
It's really hard for us investors to compare whose quantum computer is better, because you guys do not have a standard.
Well, that's an interesting question. We used AQ because Dr. Jung-Sang Kim was very focused on the actual use of the computer. We were not a toy company. We are not just a research institute or academics. We were trying to build useful, commercially viable quantum computers. And he thought of AQ as the best way to reflect how is this computer useful, right? Because like a Formula One car can't drive on any road, it's not road legal, right? Nobody except a Formula One driver can use it. So how do you get extreme power but also usefulness? That's what AQ is about. Extreme power, useful in ML, useful in these categories. But so the reason we announced, because we have been planning this for a while, our incredibly ambitious roadmap is you can see the industry is looking at these 3 things now. They're looking at physical qubits, they're logical qubits, and the thing that matters is fidelity, right? If you don't have that fidelity, that's the question to ask everyone. Because if you have 2 million physical qubits and you apply quantum error correction so that you can actually get them to logical, useful qubits, they have to have high fidelity. If you have high any qubit but low fidelity, you do not have a useful quantum computer. And if you have, as we announced, the level of fidelity that we have, that we're going to achieve, or we hope to achieve, and Oxford Ionics is already achieving world-class, groundbreaking fidelity numbers, right? So once you have those 3 things, then you have power, you have incredible scale, and then you have usability. That's how I would think of those 3 things, and that's how you should look to judge us and the rest of the quantum community. The last thing I would say though is, and ask who is using your quantum computer, and can I use your quantum computer? That's why we're on all 3 clouds. Then we have a lot of feedback from hundreds of thousands of quantum developers on AWS, Microsoft, Google. So we get a lot of insight and input. And then we work directly we signed an MOU with KISTI, directly working with KISTI, some of the best scientists in the world. We signed a deal with AIST, one of the most preeminent research institutes in Japan. We work with Oak Ridge National Research Lab. So we have the academic research community, and then AstraZeneca, a real commercial company that their highest levels of profitability or highest levels of cost are all related to drug discovery. So Then you go, great, you're working with AstraZeneca. ANSYS is not that well known and potentially in Korea, but it's one of the largest, computer-aided engineering companies in the world. And what they have, which we really want, they know every company, any large company working on hard problems using HPC. All the people who are using HPC and they don't get the answer they want, we're giving them another tool for them to address the problem. That's why this partnership with ANSYS is just fantastic.
So can we understand that the reason why you guys moved from AQ, the logical qubits, physical qubits fidelity, is to have a more fair comparison with other companies, since you guys launched the very aggressive roadmap?
We see that the industry and customers want to know these numbers.
Right.
The really nice thing is internally, like I literally talked to a customer, I can't say who they are, but they had actually used both IBM and IonQ for their use case. And they said to us, and this is the current qubit count we have. So even if you use, an IBM quantum computer that has a higher qubit count than ours at 36, they said the outcomes were better on IonQ. And again, it's why, because we have higher, better 2-qubit gate fidelities, superconducting word, all-to-all connectivity, like those kind of things, coherence, very long coherence time. When you have that comparison and you need to get an answer, the researcher or the commercial company or the academic goes, okay, I found great use and commercial viability in this platform. So that's why we get so many early signals of how useful our quantum computers are now. So that's why narrow. It doesn't address every use case in the world, neither did Microsoft or NVIDIA. But key use cases that are meaningful, that get progress and that get revenue, right?
The next question, after acquiring 7 companies, what is IonQ ultimately aiming to achieve through this strategy? Additionally, what are your key financial goals or targets as you look ahead to 2030?
I think, as you had heard, Peter Chapman, our former CEO, who's now our executive term, had said that we are very much focused on getting to profitability and getting to $1 billion. So those are still our North Star of what we're hoping to achieve. I think from a acquisition perspective, every acquisition we do is a strategic acquisition, well thought out, in order to actually land the roadmap, land the not just landing the roadmap, but landing the use case and the applications that will be used on those. We're hoping to build the world's most powerful quantum computers. And then we don't stop there. The next part of the sentence is to solve the world's most complex problems, because that's what the world needs.
And then once all recent acquisitions are completed, IonQ's headcount is expected to grow to around 900 to 1,000. So that's our expectation. And integrating the technologies, cultures, and talents from multiple organizations is never easy. How is the company managing this integration to create meaningful synergies?
What's very exciting is if you think of the leadership team of IonQ, we have a lot of people who are professional managers who have been at companies that know exactly how to integrate. Rima, who came from Cisco and from NVIDIA and started also in Solaris. I came from Microsoft, and I actually had to do several acquisitions where I helped with due diligence, and then I actually had to integrate the companies into I used to run security for Microsoft, so I integrated 2 security teams into my group. And then you think of Thomas's background, at whether or not it's Oracle or Siemens. You think of Nicolo's background, his ability to understand how to bring disparate parts together and make synergies happen. You look at Ariel, our SVP of product, ex-Google, ex-Cisco. So when you think about all these people, we are professional business people, incredible fans of the technology. I hope you think we're good at our function, but we also understand how to build teams and how to grow, putting together teams from different areas. I've been incredibly excited. I got to visit and talk to the Oxford Ionics folks, Dr. Chris Balance, Dr. Tom Hardy. They're incredible. Met all of their senior leadership team, incredibly enthusiastic. We're in the same space of trapped ions. I've seen the physicists talk to each other. A lot of them grew up together. They studied together. So you have that. I've been closely talking to the Capella Space people, and then that's an acquisition that we're looking to close. And they're unbelievably excited about this combination because they said they always knew that for the satellite and space business, they want to grow the QKD business. That's a huge part of what they were looking to do anyway. So when they see that we have ID Quantique's expertise, we have Cubitech's expertise, we have Capella's expertise, and then we have Oxford Ionics and LightSync, you put that together, it means we're building incredible hardware. We have incredible folks on the software team because we've been growing that software team. We have world-class application folks. So then you have quantum computing and hardware and software and apps, and then you have networking. And so I like to say we care about the full stack as well as networking to actually extend and expand and scale. So you will look at IonQ as we can help on the ground, in the air, and in space. And I'll explain the air thing because no one understands that. I was like, air, why air? But I use air because right now, if you think of the quantum internet, as we build out the quantum internet, we are not laying new fiber. The existing fiber optics that currently build the internet right now, we need to use that. So some of our contracts with the Air Force Research Lab, one of the contracts is literally about down converting quantum to work with existing fiber. Another part of that contract is working with on ground to the air, unmanned aerial vehicles like drones. So we're working on the ground, right? Cubitech's EPB network, and then we are now working on in air from on the ground to air. And the incredible addition of Capella means we are now going to focus on how do we get quantum in space. How do you get that incredibly secure connection as well as the global visibility around the world? I wanted to tell you, I was doing an interview yesterday and somebody asked me why is South Korea a great place to invest in and what's helpful for as a growth, and why do we invest here? And I said, I think South Korea has incredible resilience and grit and a work ethic that is astronomically great in the world. And then you have the most incredible scientists and talent. The number of university students that came up to me to talk to me has been delightful. The number this year versus last year, all universities coming in. And then the other thing I was thinking of, because you have companies like Samsung. Samsung was an early investor in IonQ. And you have LG, who we talked to and is incredible. They have this beautiful booth there. And you have, Hyundai, who we've talked to and worked with over and over. These are innovators, they're pioneers, and they're creative, and they're bold. All of the reason why South Korea has invested heavily in quantum and why I believe South Korea will remain one of the biggest leaders in quantum, those aspects are like us. And those are the things we want to combine with and work with companies and countries because that reflects our goals.
Are there any other ongoing discussions to acquire additional companies, or are you guys open to acquire more companies?
We have no announcements at this time to make, but we are always looking to continue to grow our company and hit the goals that we see.
There was a rumor that IonQ got some suggestions from bigger companies to sell the companies to them. Can you comment on any of those aspects?
I think there are lots of rumors like that, but none of them are justified or things that we talk about. Because, again, as you can see, we raised money. We're very well capitalized. We also are able to acquire and grow our roadmap and accelerate it. That's our plan. That's the plan we're working on, right?
From our perspective, IonQ might have two options: to become a big tech by yourself, or integrating with other companies to have a bigger synergy.
Right.
So you guys could, consider between those two options in the future.
Right, and I think those are all business decisions that companies make. But again, back to what we're focused on, we're focusing on growing IonQ. That's why you've seen that we've done the acquisitions we've done.
Right.
We have an ambitious roadmap. We're partnering. The two biggest companies that have been so incredibly great partners for us and we learn from and we work with are AWS. You know, they renewed a multi-million-dollar contract. They're very excited when we're on Amazon, you know, AWS bracket. We just announced the partnership on the application we launched at ISC. And so, like, when you have NVIDIA, who, I have to show you this photo. Maybe I'll show it to you. I haven't actually posted this photo yet, so you get to see it, and then I better actually post it, because now I'm showing it to you. But look at this photo.
Oh, you took a photo with Jensen.
Yeah.
Where was this?
This was actually at GTC in Paris.
Paris?
Yeah.
That's
so,
like 2 weeks ago?
Yeah. So I think, I only show that because it was just funny, because he, at the GTC Paris, he got up on stage and talked about the different platforms. He clearly, explicitly said on stage, the different platforms. Every year I go to GTC and I say, what are the next platforms that we're trying to help create? And he said quantum. He said the fifth one is quantum. And he also said on main stage, he says, I see quantum at an inflection point. So all of that's been fantastic. We work closely with their team. We work really hard on making sure that we know how to leverage CUDA-Q and be able to create hybrid services. And that's unique, because not a lot of other quantum companies are doing that. And why do we want to do that? Because NVIDIA is an incredible partner, AWS is, AstraZeneca. If you put three mega respected companies that are great at their space and we provide quantum expertise, then we get great outcomes, right? The best and the brightest in the world working on the same problem. That's how we want to grow and how we want to play.
I remember that Jensen he mentioned that every supercomputer will have quantum in the future. So do you think that's the mega trend where quantum will be in the near future, working together with the supercomputers?
100%, because right now we need supercomputers, right? There's no quantum solution that doesn't have a pairing with a HPC or a supercomputer. And it's a symbiotic relationship, right? You know, like, for example, a supercomputer or an HPC computer will be looking at an AI problem. And they look at an AI problem, like the problem is ChatGPT. They're like, okay, we're now at ChatGPT 4, or we're at trillions, of parameters. And ChatGPT gets bigger and bigger and bigger. So the compute power that's needed to process ChatGPT 4 versus 1 is astronomically different, right? When you're going from millions to trillions. And you have all of this great power in the supercomputers using, NVIDIA's GPUs. So you get all of this power. But one of the problems with having that hungry, LLM is what? Energy. It costs a lot of money to run all of that. So one thing we're working on with lots of different partners is, since quantum is very good at things like, pattern detection. So, LLMs and ChatGPT, those are about pattern detection, right? Patterning, looking at a lot of words, figuring out this massive database of parameters. How can I come up with an answer? Quantum is very good at that as well. So you put those powers together, and let's say you run a huge LLM on a HPC. You take one level or one layer of that large language model problem. It's usually linear algebra. You pull that part out, and you have this still running, right? Classical compute. You give that workload to a quantum computer because it's symbiotic, because quantum will solve this particular LLM linear algebra problem differently than this full stack. And then you work together. Quantum will get input from classical and back and forth. But we're hoping that quantum will reduce the energy load of LLMs and data centers using AI. And we hope to use quantum to help accelerate. Jensen says this. He often says it's quantum enabled, quantum accelerated, and that's what we both believe. So.
Do you have any plans to raise more capital in the next 12 to 18 months through equity, debt, or other instruments?
We haven't announced any type of plan for that.
Okay. And then recently, insider stock sale plans amounting to nearly 4% of the total shares outstanding have been disclosed by Rule 10b-5-1, and a significant portion of those sales is already underway. Could you comment on this part?
So, as you know, 10b5-1 plans are plans that are instituted way in advance for insiders to be able to trade with no insider information.
Right.
That's the reason they exist.
Uh-huh.
And for a lot of people at the company, we have a lot of insider information. And it's only fair that they do not take any advantage, and that's why they put those plans in, right? So, I mean, we're highly ethical. I love this company. We always try to do the right thing, and in that case, that allows, you know, insiders to sell. Those plans were made, you know, months and years in advance. And then any particular trade that somebody has, we don't comment on someone else's personal financial portfolio.
But we were worried about the amount of sales that were coming. It was like 10,000.
Right.
So
again, if you imagine that the roadmap that we just announced, a lot of the parts of that roadmap we have known for a long time, but also some of those parts, or the fact that we are able to actually close, you never know if you're going to close an acquisition. We're incredibly happy we closed the IDQ as the majority shareholder. We're incredibly happy we closed Cubitek. We're incredibly happy we closed LightSync. So you don't know if you're going to close. So anybody that is betting on IonQ, you bet on the company with your life, and you bet on it way in advance before you know the outcome, right? And that's all those are. So I wouldn't look at that as any indication from internally. I mean, look how excited I am. I'm very excited.
Yeah, I asked this to Timothy or Nicole, that you guys receive a lot of stocks as a compensation, a part of your salary, right? So do you expect the stock price will go up in the long term? I bet you guys are, but how confident do you feel that?
I think we're all betting with our life.
Right.
That IonQ will continue to be successful. That's our goal. When anyone says, hey, how much do you believe in IonQ? I say, well, I work 20 hours a day. And,
that's a good answer.
Right?
Yeah. And what are your thoughts and opinions on the looming threat of post-quantum cryptography and quantum attacks in the near future?
Well, I think we focus on being the white hat hacker. We focus on building and delivering quantum to enable good things and to prevent bad things. So like I said, I worked on security at Microsoft for 3 years. I'm fairly deep on security, and as you know, post-quantum cryptography indicates that there are algorithms that you're creating now to prevent when, not if, when the quantum computers are so powerful they can break RSA 2048. And you know, we actually as IonQ, as part of our acquisition of ID Quantique, as well as what we've been working on internally, we are focused on quantum key distribution. It's a part of the portfolio of what we sell. And quantum key distribution is 100% part of the security landscape, right? Of how do you actually continue to have very highly impenetrable, secure communications. And then post-quantum cryptography, like, we are 100% working on making sure that we have internally and externally, we partner with the good guys to make sure that we want our quantum computers to be used for the good of mankind. Even Apple, right? Apple, who is a consumer product, right? Their iPhone, they implemented, you know, a different level of security on iMessage, right? They actually had a blog post about post-quantum cryptography. They said it will be coming and we will be ready. You know, WhatsApp and Signal also had that as well. But when you think about a consumer company saying that, and us as a quantum company, we need people to be aware, and then we all need to work together to actually create the algorithms that offset what a quantum computer can do. Quantum computers will both be able to break encryption and stop it from happening. That you need that power on both sides. Because right now, right, it'll take, even just for 256, or any level of encryption that exists now, for classical computing to break encryption of 256, it'll take like hundreds of millions of years. One day, and it's very soon, when we have a quantum computer with that large number of qubits and logical qubits, the space, computational space expands dramatically, right? And it is believed that one day, when we have those computers, quantum computers will be able to break that level of encryption in hours or days.
I recently figured out that Chris Monroe has returned to IonQ as Chief Scientific Advisor. So I'm curious to understand the context and implication of his return.
Well, what's really exciting is that we're still maintaining close ties with our founders.
Right.
And Chris Monroe has actually he's in the same space as us, trapped ions. And he, at his lab, has been hitting world records, trading it off with Oxford Ionics and hitting them. But he has also been very instrumental in giving us guidance and continuing to give us guidance in the trapped ion space. So given he was doing it for us and he's in close partnership with Niccolo, we decided that we should make it more official because he is giving us scientific advice.
Right.
So it was really exciting.
What we thought was that since photonic interconnect is a really hard technology to implement commercially,
Yes.
we thought Chris should step in and help more directly IonQ. And then you guys have to integrate the Oxford Ionics technology as well, right? So that's where Chris has to step in. So
He isn't taking an operational role because we are in charge of the operations of the photonic interconnect scaling that we're getting from the Lightsync acquisition. It was closed. Dr. Mihir Bhaskar now works at IonQ, and being able to go from no memory to memory enabled and being able to get that kind of 50x scaling capability. 50x scaling because of the technology they have that enables better entanglement for photonic interconnects. That capability is embedded in IonQ already because Dr. Mihir Bhaskar works at IonQ.
Right.
He's a fundamental member of the engineering team. We already had photonic interconnect expertise through our entangled networks acquisition. Remember that one?
Right.
So we have that deeply embedded in our company already. So that operational work, some of the best and brightest minds in the industry on photonic interconnects, we have them. And then the Oxford Ionics work is, because that scales up once you have 2 chips.
Right.
If you can get more qubits, and in the chip using, off the shelf, semiconductor, if you could do that, that's the best of both worlds that we're working on. Because the one fundamental that we know in trapped ions is we have a layer of, like I said, better coherence, we have better fidelity, like that in all-to-all connectivity, that with more qubits on chips and the ability to scale them and network them, that's our goal. Chris has been incredibly advising. He still mentors and advises the physicists, but the operational work of the integration and building upon what I just said, that's solely in the hands of the engineers and the integration folks and all of us at IonQ.
So Chris is working part-time for IonQ, so he'll receive RSU, PSU, all this.
I can't comment on how he's being paid.
So we remember that Jung-Seng, when he left, he was the chief scientific advisor, right? A few years ago. So does that mean their role changed?
I think there will always be chief advisors and scientific advisors to IonQ. They co-founded the company.
Right.
They made the breakthroughs in the trapped ion space, as you know, Chris did 30 years ago, right? Being able to showcase how trapped ions was ahead of all the other modalities. And, as I said, Jung-Sang had always had a vision of usefulness. He was very focused on AQ because he wanted to make sure that the computers were useful to end customers. So that had always been great, our great heritage. With Peter Chapman that came in Niccolo, they're looking at how do you expand commercially and get even larger and bigger with more customers, more partners, with bigger and more ambitious plans across this entity of quantum computing. Because quantum computing has grown since they started the company. And so now we're all rising to the level and excitement of the momentum that we're generating.
But aren't you worried about the sales if U.S. government intervenes and they make export controls like they did on the semiconductors to China, Russia, or other countries? We don't, for both export controls and tariffs, we get this question a lot. And I think the really great thing is we are a U.S. company. A lot of the deals, as you've noticed, were shipped in the U.S. The last deal that we talked about and we announced, the EPB, is the first utility company that has both a quantum network and a quantum computer. That's a quantum computer, a Forte Enterprise, that will be shipped to Chattanooga, Tennessee.
So we have a lot of traction and a lot of great relationships, customers, partners, as well as academic institutions in the United States. So that's always fundamentally been a really great part. And again, we have existing U.S. Air Force contracts that we're working with. We have, we work with ORNL as, an entity in the U.S. With that said, we have Switzerland with IDQ as well as Quantum Basel. With that said, through our ID Quantique, majority shareholders of ID Quantique, we actually have a presence via their entity in South Korea. So that's great. We have, we're working closely with researching companies in Japan. So we do look at key countries and key opportunities where it makes the most sense.
More friendly.
Yeah, but if you think about it, obviously the U.S. wants to win versus China.
Right.
China keeps saying they've hit quantum advantage, but it's hard to believe it because there's no integrity of IP and there's no integrity of you have to say the truth, right, in press there. So the U.S. and our allies, the UK, Oxford Ionics is in the UK, our allies here in South Korea, our allies in Japan, we need to win as entities against that threat because China invests a lot of money. But so there's that, and then the second part is the biggest compute countries in the world, because I worked on compute, I worked on servers, I worked on operating systems, they haven't changed. So remember, if we think I want to have a quantum computer in every data center or a quantum chip coinciding with a supercomputer, like how Jensen talks about it. If I want that, then where would be my target audience? It would be where do people use compute? Besides China, the biggest compute markets are the US, UK, Japan, Germany. They haven't changed. And then in South Korea, what you really have that's great is you have the users that need quantum. Right? Hyundai worked with us early on because they understood that they have to make, they have to look at their battery composition to make better batteries for autonomous vehicles. They need to look at object recognition for autonomous vehicles. They need to look at, we published a paper with them recently on looking at the microstructures of steel. Because imagine everything that's built in the world that's made of steel, ships, cars, airplanes. You want to make sure that you increase the stability and hardness of it so that they're safer. In England, they have banks. In England, they have, England is actually one of the top 3 tech industries in the world. It's not that they have all of the companies that are all started there, even though Oxford Ionics has started there. They have a huge tech industry. Why? Because imagine ARM. ARM is in England. Their top 5 customers are American. So if you know that you have this symbiotic relationship of working with different countries that already use computers, they already need HPC, that's when you think, oh, that's why we want to work in those countries, right?
As an investor's perspective, I hope IonQ follows Palantir's path. That's what we are expecting.
Right.
So I hope it gets bigger and better than Palantir.
We have incredibly big ambitions, but we're very confident. We have the right people, we have the right technology, and the right partnerships.
And so that concludes our interview. So thank you for your time, Margaret. So we hope to see you next year as well.
Absolutely. Thank you very much.
Thank you.